All right, let's talk about what the word magnitude means. Magnitude is how much of something you have or how many you have. So for instance, if you are driving at 62 miles an hour down the freeway, the magnitude of that is 62. So essentially, when you have some sort of quantity, the magnitude is the numeric value or the number that you see. So you can see I have some paper clips here. The magnitude of paper clips that I have is 4, because I have 4 paper clips. Sorry, that was kind of a plain analogy. I'm just flying by the seat of my pants here, just winging it. So just roll with it. Yaw, yaw, yaw. Props to you if you get that one. Okay, now let's talk about 2 very important words. Let's talk about the difference between vectors and scalars. Scalars are things or quantities that measure magnitude, while vectors are things or quantities that measure both magnitude and direction. So the key difference between a vector and a scalar is that vectors also include a direction. Scalars do not, only the magnitude, or just the number with the units. An example of a scalar would be speed. For example, you could have a speed of 4.7 meters per second. So you can see that this speed has a number, 4.7, and that is the magnitude. An example of a vector would be velocity. And you could have a velocity of 4.7 meters per second left, or right, or north, or east, or up, or down. So a speed just has the magnitude, the 4.7 meters per second. The velocity has the magnitude, which is the same, 4.7 meters per second, the number, but it also specifies the direction. If I say the speed is 4.7 meters per second, I could be moving at 4.7 meters per second in any direction I want. I'm not specifying in which direction I'm moving. By saying the velocity, you specify how fast you're going and in which direction you're moving. Another example of a scalar would be distance. And the corresponding vector would be displacement. So distance just has magnitude, while a displacement has magnitude, or the number, and a direction. If you see a variable, for instance, the variable v, which usually stands for speed, right? And you see it with a little hat like this, that is a vector hat. So when you see this little half arrow on top, that is telling you that this variable is a vector. So if you know that v stands for speed and you have this half arrow that looks like a hat on top of the variable, then you know that this variable is a vector and it's not speed, it's velocity. We represent vectors with arrows. Okay, this arrow is a vector. This side of the arrow is the tail of the arrow, and this side is the tip of the arrow. Vectors have length and direction. What that means is when you're drawing a vector, its length matters and so does its direction, because a vector with a different length is a different vector, and a vector with a different direction is a different vector. So this arrow here and this arrow here have the same length, but they're pointed in different directions, which means they're different vectors. This vector and this vector, they are pointed in the same direction, but they have different lengths, which also makes them different vectors. The cool thing about vectors is that you can move them anywhere on the page. I can take this vector here, and I can redraw it over here, like copy and paste, and it's the same vector. So I basically just copy and pasted that arrow into a different place, and it's still the same vector. I could paste it over here, 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 and it would still be the same vector. So you can move vectors anywhere. What you cannot do is rotate them. You cannot rotate a vector. Why? Because once you rotate the vector, you've given it a different direction. And that makes it a different vector, which is super key. Because if you have two vectors that are the same length, but they point in different directions, then those are two different vectors. The cool thing about vectors is that you can combine them together or add them together. When you're adding vectors, you connect tip to tail. So you connect the tip of one arrow to the tail of the other arrow. Let's do an example. So here I have 5 vectors, 5 different vectors. I've drawn them all in different colors so that you can follow how I combine them together. So I'm going to combine these vectors tip to tail. So I'm going to start with one arrow and connect it to the next arrow, then connect it to the next arrow and see what happens. And so remember, I can move vectors around wherever I want as long as I don't rotate them. So okay, I'm going to start with the purple arrow. You can start with whatever area you want. So I have redrawn the purple arrow, and so I'm going to connect it to the red one next. That's my personal choice. So I'm going to connect the tip of the purple arrow to the tail of the red arrow, which means that I'm going to draw the red arrow right here. Okay, the tip of one arrow, the purple arrow, is touching the tail of the other arrow. I'm going to do the green arrow next. So I need to make sure that the tip of this arrow is touching the tail of the green arrow. So I'm just going to draw it like this. I'm going to move on to the blue arrow. So connecting the tip of the green arrow to the tail of the blue arrow. And last but not least, the orange arrow. I'm not rotating it, just starting at the tip of the blue arrow and drawing the orange arrow in the same direction that it was up here. So this is how you combine vectors. Okay, so when you have this open tail of an arrow and open tip of another arrow, you want to connect the open tail to the open tip. When you do that, the resulting arrow that you draw is called the resultant. So let's do that on our picture and I'll show you what I mean. So this is my open tail, this is my open tip, and I draw my arrow from the open tail to the open tip. That is my resultant vector. The resultant is always from open tail to open tip. So what is this resultant? Well, let's pretend you were walking. You were walking from point A to point B, okay? And so when you were walking, you could have walked along all these colorful arrows, all these vectors that we had in the first place. You started at point A, you followed these vectors, and you got to point B. Well, if you'd followed the path of the resultant arrow, you also would have got from point A to point B. So the resultant arrow is the result of adding up all your arrows together. The result is you getting from point A to point B. This one resultant vector is the same as all of these small individual vectors combined together. So you might be wondering, does it matter what order I draw all these arrows in when I'm adding them together? It doesn't. No matter what order you draw all these arrows, your resultant arrow is going to be the same. Let's do it a different way and I'll show you what I mean. Let's do it again, but using a different order of adding the arrows together. So let's start with the orange arrow down, for instance. Okay, I'm going to go green arrow to the right. Again, connecting my tip of the arrow to the tail of the next arrow. Okay, let's go purple arrow. then blue arrow, and finally the red arrow. So again, I just kind of chose a random order. Doesn't matter what order you draw them in, as long as you're connecting tip to tail, you're not changing the length of any of the arrows, and you're not changing the direction of any of the arrows. And so this is point B, this is my ending point. And so to get my resultant, remember I connect open tail to open tip. So I'm going to do that. This is my resultant. And you can see that this resultant has the same length and is pointed in the same direction as the resultant was over here. So it doesn't matter in which order you connect all these arrows, as long as you are not changing their length or their direction and you're connecting tip to tail. So I've just combined a bunch of vectors together to get one vector, or the resultant. But can I do the opposite? Can I break down one vector to get many vectors? And the answer is yes. Alright, so I'm going to draw a diagonal vector. This is my tail, this is my tip. The tail is where you start and the tip is where you end. So I'm going to call the tail point A and the end point B. Okay, so if I want to break this vector down, I have to start drawing my arrows from where the vector starts, and my goal is to end up at point B, where the vector ends, but I want to do it in a different way than this vector drawn here. So I can break this diagonal vector down into its components, meaning I can break it down into horizontal and vertical vectors. So I'm going to start at point A, or the tail of the vector, and I'm going to draw an arrow to the right, because my goal is to end up at point B. But I want to do this using only horizontal and vertical arrows. So I'm going to go to the right, because I want to move in the direction of point B. No diagonal lines. As I'm breaking this vector down, all of these arrows still have to be connected tip to tail. So the next vector that I draw needs to connect to the tip of this arrow. And so my goal is to get to point B, but I'm only drawing horizontal and vertical vectors. So I can draw a vertical arrow up to point B. So I just broke this blue vector down into two component vectors. That's a fancy way to say that. I broke the diagonal line into its horizontal and vertical components. Or I just broke one vector down into two vectors. And so that's the cool thing. You can break any diagonal line into a horizontal part and a vertical part. So if you have a diagonal line, you can follow the diagonal line, but moving at a diagonal is the same thing as moving to the right and then going up. So you can look at it either way. You could delete the blue vector because following these two vectors gets you to the same place as moving in a diagonal line. Another way you can think about it is that the blue vector is the resultant of adding the red and the purple vectors together. Because if you connected the open tail of the red arrow to the open tip of the purple arrow, you would get the resultant vector, and that is the blue arrow. It is the result of adding the red and the purple arrows together. What do we want to get from all this? Well, you can break down vectors or you can put them together. So once you've broken down a vector into its separate parts, you can move those separate parts around. So I can move this red arrow over here if I want to. I'm allowed to do that because they're vectors and you can move vectors around. Hope this video pointed you in the right direction.